Good afternoon, or I guess it's still morning. Thanks for having us today. We're going to talk about BIM MEP fabrication, from design through to fabrication out into the construction site and back. Myself, I'm Paul Bardati. I'm from Redcage. Bill Wright is with me as well here. He's also from Redcage. So a little bit about Redcage. We won't dwell too much on this. We want to get into the meat and potatoes here. But we're an authorized Autodesk reseller. We focus on working with clientele on bettering their BIM process. We don't really focus extremely a lot on trying to sell software. We feel that that comes if we're showing you how to use the software better. We're specialized in the design realm of Autodesk products, so all of their AEC product line, as well as we have the advanced MEP Fabrication Specialization, which simply means that we've gone through a certification process with Autodesk to ensure that we understand that workflow, we understand that industry segment, and we bring expertise to the table. We are currently the only Canadian authorized specialized advanced fabrication reseller. We only employ industry-specific people. And when I say that, what we do is we look for people that have worked in the industry with the software. So we feel that that brings a lot of value to our clientele, because if they don't know what you live and breathe every day, I don't think that they can help you as well as somebody that does. So that's what we look for in our employees. We're located out of Mississauga, Ontario, but we service all of Canada. So a little bit about Bill and my excellent adventure. We're both architectural technologists by trade, been educated in that field. We've both worked in engineering and architecture firms over the course of our careers. And we've been tied together since 2007, which is in and around the time that Revit or Autodesk came out with Revit MEP, a little bit before that. But all intents and purposes, 2007 was kind of when we were starting to see traction in the industry with Revit MEP. So we've been doing a lot of work on Revit MEP since then. We've learned along the way when we engage clients and try to help them better their BIM, that it's not just about training. To train somebody is one thing, but to actually apply what you've learned on a project is a whole complete different thing. And really that's where success is stemmed from. When an individual can take the software and use it and apply what they've learned on the project, that's really when the rubber hits the road. And you can see that we've worked with quite a few different firms in the realm of MEP as well as fabrication. This thing's not working. So a little bit, oh, I went the wrong way. So a little bit about the product line. Autodesk currently has what's called the MEP Fabrication Suite. They have recently announced that they're going to bring that to an end of life at the end of January next year. Very similar to what they've done with their other suite offerings. Currently, this setup or this suite comes in around just shy of $6,000 a license, a single user license. When they do that transition over, they're going to go to their collection offering, and then you will add the additional applications, which are basically the three top ones and the green point layout. At that point, the price will jump quite a bit. We still don't know exactly how they're going to handle that. We're kind of hearing that they're going to do something to bring it more in line. But if you have an interest in this workflow that we're going to go through today, I would suggest that you maybe take a look at it before January 31st. So a little bit about the Fabrication Suite, and then I'm going to hand it over to Bill, and he's going to go more into the workflow specifically. So one of the biggest advantages of this Fabrication Suite is throughout the whole product line, all of the various applications, it's got a common ITM database. And what that simply means is there's a library of content that's specific in the program. It stems across all of the applications, so everything's talking the same language across the board. This is very important because it's spec-driven and it's based on classes. And it's throughout the product. So there's no incompatibilities when we go from the detailing side of things into the estimating side of things and then out to the plasma cutters. It's all talking from the same content database. So I'm going to turn this over to Bill, who is going to be able to tell you a lot more specific details about workflow than I can. So Bill?
The green.
All right. Thanks, Paul. So yeah, what I'm going to talk about here is the Fabrication Suite workflow, how it gets integrated. Now, you can either use it collectively or you could use it independently. So I'm going to kind of show a bit of both. But if you're only an estimator, then you could just purchase just the estimating side of things or just use that. If you're more of a fabricator contractor that uses all the detailing side, the estimating side, the CAM ducting side for fabrication, then you could utilize the whole suite. So what we have here, oh, it didn't play my video. There's supposed to be a video here, but it's not playing. So I have a video here. This is over the time I've worked with some fabrication companies. We've developed a workflow video that will show how we can integrate from a Revit workflow to a CAD duct or CAD MEP workflow to an estimating workflow. Or what we do is we custom tailor these workflows when we work with businesses so that they can only focus on one core area. So like again, if you're just an estimator, then we'd just focus on the estimating side and we'd build a workflow that's apparent to that. This is all cloud-based workflows. If you go into one of these, we'll generate how your users could step by step go through converting fabrication parts and each process of that workflow. So we kind of do this. This is one of the things we do. Instead of just regular CAN training, we do a lot of custom training, a lot of geared towards your workflows, develop workflows with you, build standards, build templates that will help you propel a lot quicker within your fabrication space. The first workflow I'm going to talk about is the Revit Fabrication workflow. And Autodesk years back bought a software called MEP software, and that's where all the ITM database came into play. By buying that software, they're now giving you the ability to create LOD 400 models inside of Revit if you want, or you could be outside of Revit. So level LOD 400 has been somewhat possible through third-party apps, but not a tight integration with the Autodesk package. So I'm going to go through laying out, converting, and supporting inside of Revit fabrication. So back in 2016, Autodesk put some fabrication tools in Revit, and it got even better in 17. 17's given us the ability now to do things like routing and filling based off of a service type, and based off of that route and fill, we can trim, extend, and slowly develop a fabricatable model, kind of piece by piece. One of the huge benefits it has is it will also connect to regular design ducts, so if you're only focused on maybe a mechanical room, it'll also just connect to that main design duct outside of there if you want to. So you can do all your fab of a mechanical room and just tag out to an actual regular design duct, which is quite nice. I think 2018, we're going to probably see a huge improvement on the fabrication space, so inside of Revit, and I think that's kind of the direction Autodesk is going, so that might be quite nice to see as well. We now have the ability to insert parts, and anyone that knows when they try to use Revit for some sort of fab or process, inserting a part is quite complicated. You can't rotate a valve easily without cutting a bunch of different views. With the fabrication tools, we can rotate a valve 1 degree increments if we want, roll it off the pipe, off the duct for the duct fittings and so on. So it's a lot smoother process than just throwing a valve inside of Revit. And the key here is the manufacturer content. So they have a content database of 65 different manufacturers, and we can even create our own if we want using a lot of the parts capabilities inside of CAD MEP. The huge benefit here, this workflow mainly is going to be a massive benefit. We've got a lot of fabricators moving towards Revit for this simple reason. If they receive an MEP model from a design company, a consulting company, what they're doing is they're quickly taking the design layout of ductwork and piping and so on, and they're converting it to fabricatable parts by just a couple clicks of the button of the mouse. And what that's going to allow them to do is now take it into that LOD 400 state and then start to fine-tune the model a little bit more. If they're not receiving a BIM model because, a lot of consultants, I'm not sure why, maybe not playing nice in the sandbox, they want to charge fabricators for these content, for the model and so on. And if that's the case, a lot of fabricators are simply just remodeling the building anyways, right? They'll refabricate it using Revit as the starting point. So whether or not they're getting the model, there's a workflow if they don't receive the model, right? And if you're an engineering firm and you want to go to this level of detail with truly mechanical manufacturer spec stuff, you could do that as well. Lastly, one of the things that allows us to do here inside of Revit is to optimize our ducts. So currently, if you draw a fabrication duct, you want to optimize it to be its proper cut lengths for the fabricator, for the sheet metal contractor. And they can quickly take this into CAM duct and start to cut it on their machines. You can see we can extend elbows, make transitions, stuff that you can't do in Revit that takes a lot of time. And especially extending those elbows, it would really require a custom fitting in a way. So it's quite nice in some of the tools that I have. Also supports pipe hangers, duct hangers, cable trays, and conduit hangers. Inside of Revit now for fabrication, we can connect hangers to other hangers, cantilever hangers, even attach hangers automatically to structure. So if there's a structure above from the engineer and it's a linked model, we add some hangers, they'll automatically find the structure above. From that point, you can go into like a point layout workflow, and you can start to lay out all the points where those hangers are for building on site, right? So quite powerful features that we got going on here for that. Then that stems me to, I feel like I'm talking really fast here. This stems to the Revit design to CAD MEP. So let's say, for example, one of the workflows is the engineering firm just is not giving up the model. Well, from a fabricating standpoint, if they're willing to take a 3D view and go through a MEP to fab workflow, they can actually send us a RIF file, and we can convert that RIF file into our services inside of CAD MEP. And it will quickly take the design intent model, and it'll start to put in the fabricated service and automatically convert it to cut lengths and so on. So there's a workflow there, or if they are receiving a model and they're more comfortable in CAD MEP, because let's face it, not everyone has BIM users or Revit users. A lot of them are still CAD operators today, but they know the process in 3D CAD, then that's a workflow they can go to, and we can eventually branch them to that Revit workflow, which is quite nice. When you take it into a CAD MEP workflow, I forgot to take those animations off. It's CAD MEP workflow. So after it comes from a Revit, you get these things called design lines. Those are those single lines up there, and design lines can be converted to any service type, a supply line, a return line, whatever, and it'll apply that spec to that design line. And the design line, you can add additional design lines quite quickly. You can modify them if you need to, but that design line is quite powerful in the CAD MEP world for those detailers, because they can just work in single line and convert to 3D if they want. So that's one of the workflows that they'll use there as well. What you see on the left here is just the design line and the spec that is being pulled for modeling purposes. And who says Revit can't spool? I mean, it's been a pain point question year over year. You know, Revit can't spool. Well, Revit can spool. There's a bit of a workflow to that. So if you're more comfortable and you want to take your models and you want to spool in Revit, we can do that. We have a workflow for that. If you want to take your Revit model into CAD MEP and spool there, you could do that as well, or just spool directly in CAD MEP. So there are workflows for it. Everyone always complains that you can't spool in Revit, but you can, right? So we have some of those workflows developed, and that's kind of nice about what we do, is that if I'll sit down with a company, a fabrication company, and we'll talk, how do you prefer to spool? And I'll demonstrate a couple different ways, and then they'll come up with, you know, which process they like best. That stems us to Est MEP. So that was more on the detailing side, and now we come into estimating side. So if your mainly focus right now is to bid on a job quite quickly, we could take a Revit model, spit it out to an MAJ file, which is another format, and bring it into Est MEP for really quick estimates. So if you're taking a model from an engineering firm, then we can convert it quite quickly to our services and then run an estimate on it based off the price data that you input or downloaded price guides that are currently up to date. You'll get information like labor rates, how long it's going to take to install, what the components are going to cost you, and so on, again, based off the information that you create. You can generate some reports at the end. And the biggest thing is that the ITM database, that's the key. So if I make a change to any one of these components here in my estimating world, that will replicate all the way down to my detailing and my fab world, my camming world. And after estimating, we can come into maybe a CAM duct. So whether you're a sheet metal fabricator or you're all in-house shop, you can now spit out your sheet metal to a CAM duct. And then inside a CAM duct, we can auto-nest From auto nesting, we can generate our printouts, so you can print out the part labels, barcoding labels, put that barcoding label onto a component, scan it with your phone using Tracker, and then find out when it actually gets delivered to site. And then they can scan it at site, and then you can know that that object has been delivered. So a lot of these labels are auto-generated, auto-created with CamDuct, and we can just spit them in. Again, it's that one workflow. If the CAM guy decides to make a change to a tap or a fitting of some sort, that will again get replicated throughout the suite of software. And then what all happens when we go back to Revit? Well, there are lots of methods. We can export Revit, like I said, to an MHA file format that is read by the whole suite. That's the key right there. And from any modification we make in a detailed environment in Revit, in CAD MEP or further, we can actually bring it back into Revit. So this image here is a design setup prior to spitting out to detailing or design to fabrication. And then to the right is the actual as-built or final completed model back into Revit. And at the end of the day, if you want LOD 400, this is a great workflow. You can get that inside of Revit and then hand that over to the owner if you want. Autodesk does have a website where you can go and download a lot of manufacturers' content. They are ITMs. If the ITMs are not available inside of CAD MEP, we have, hundreds of different make part specs that we can build our own parts from if we need to. It's way easier than building a family in Revit, to be honest, and 1,000 times easier than creating a 3D model in CAD. So we could always do that if we want to, or we can download the actual content ourselves. I'm going to pass it over to Paul to finish this off with more of the on-site talk.
Thanks, Bill. So Bill showed you a bit of the workflow that's traditionally done in the office and down on the shop floor. So what happens when we got all of this stuff prefabricated and we're shipping it out to the site? So through some of the technology that's there from Autodesk through BIM 360 Team, Navisworks, and Glue, we can bring the model out into the field and actually use it as a resource through the construction process. So the image up in the top right there is showing you individuals on site with a tablet, and they're validating or verifying what's going on and how it's being built according to the model. Point layout, Bill touched on that. Some of the, at the plasma cutter and the folding tables, you can barcode stuff. Or sorry, I made a mistake there. That's the next one. The point layout allows you to bring the data points off of the model from the hangers and what have you, and we would be able to use a surveying head there to locate those points out on the field accurately to the model. That also helps the level 400 aspect of the as-built model coming back with accurate information according to where it's been laid out in the field. And the barcoding and tracking is where the barcode labels can be scanned when they're leaving the shop, transported out to the site, and then scanned once they're installed and in place. So again, just validating the whole process and making sure that what's been manufactured, what's been detailed and fabricated gets out and is installed in the correct location as the workflow goes through and the construction occurs. So just talking a little bit about prefabrication and modularization. So when we talk about all this type of workflow and we're bringing more of the construction tasks in on a shop floor, it allows us to now start to look at this from more of a manufactured standpoint in the shop rather than piecemealing it together as the project comes together on site. So rather than somebody going out and measuring, okay, I need this length of pipe here, and I'm going to go back on to the job site shop and cut that piece of pipe and then bring it back out and fit it in place. When we get into prefabrication with all of the technology that we've got at our fingertips, we should be able to bring this stuff into a controlled environment on a shop floor, get it produced a lot better, a lot more efficiently, a lot safer, those types of aspects. So you're starting to see some of this coming into the industries. There's some notable projects that I won't get into right now, but they've been successful projects where there's actual module design that's been done in the shop, shipped out to the site, and plugged in place almost like Lego blocks. So we're venturing down a path of very controlled construction rather than ad hoc construction. So just to summarize a little bit here, and we're almost done, the benefits of all of this workflow, obviously there's quite a few in here, but you've got a lot better coordinated data going back and forth between all of the various parties. So we start to eliminate the silo effect and bring them back really the team environment and getting everything coordinated between each party. We automate the process, obviously, because if we've got databases that are talking the same language from one application to the other, there's automation there that you're not worrying about, okay, if I've changed this here, where does that affect it elsewhere? You know, the inherent values of BIM are right there in regards to automating that process and controlling changes and revisions along the way. We reduce errors and emissions, again, because we're all talking off the same data sets. We gain efficiencies on the job site, so the more that we can produce in the shop and ship out ready to be plugged and played, the better the efficiencies are going to be on that job site, and we're going to be able to construct a lot faster and a lot better. We reduce material waste as well, so even when we look at the cam duct layout there and maximizing a sheet of sheet metal and laying things out so that we minimize as much waste that's going in the recycle bin, these are the aspects that that can have on a job, as well as the waste or eliminating or reducing the waste that's on a construction site. If any of you were on the tour yesterday and we were walking through the York subway, there was all kinds of stuff all scattered everywhere. It's a typical construction site, so if we can eliminate or reduce that, that's obviously going to have an impact on the bottom line at the end of the day, and the safety aspect of the site. So again, if we get into constructing stuff in a shop and bringing it out, there's a lot less chances of having safety concerns, or it's a more controlled environment. You don't have people wandering around back and forth that don't have a purpose on the site. So hopefully it will increase the safety aspects of the site. And we control the quality and what we're producing. So again, you know, streamlining the waste and having a better built duct or pipe or module aspect that we're putting together. So that concludes our presentation. I just wanted to let you know we're at table 4 in the vendors hall there. We are giving away a Austin Matthews Leaf jersey, so if you're a Leaf fan, come and see us. If you're not a Leaf fan, I don't know what to tell you. I'm not a Leaf fan, but anyway, so I'm happy to give it away. But anyway, we're just, there's a ballot on our table. Just simply fill it out or staple your business card to the ballot, throw it in our fishbowl, and we'll be drawing for that. I think it's on the 10th of October. We'll do that draw at our offices. And if there's anything else that you want to know about the workflow, or if you have any other questions about our presentation, by all means come and see us. We'd be happy to have a chat with you. And lastly, join us on social media. We're out there. There's how you can follow us and keep track of us. And we're always here willing to help. Thank you very much.